This meeting is now being recorded.
All right, here we go. Yep, so and it's now recorded. So Oliver, take it away again.
Thank you. So welcome everybody. Thank you for having me. And so this presentation is from the IS 2020 and done remotely, but it was planned to be held in Cape Town, South Africa. And so the title is, I present this as a case study, achieving systems integration through interoperability in large system of systems. And so what I'm going to talk about is four different topics. Obviously an introduction, and then typically a case study is presented into identifying the challenges first, and then talk about what activities were performed, and then as a result, basically the achieved outcomes and conclusions. And as part of the introduction, it's really three pieces. And the first one is to give a brief overview of system of systems, then talk about briefly the high-speed rail system as a program, and then talk about why high-speed rail is actually a system of systems. So if you go to the our standard 15288 to the Annex G, you see that it talks about the application of 15288 to system of systems. And so a system of systems, if you read the definition, and it's a system of interest whose elements are themselves systems. So basically the subsystems are big enough that they're still systems. And each of those systems that are called constituent systems retain their own management, goals, and resources. And that's quite a challenge. So another thing with the system of systems is that characterized, and I have to move something over here, see what I can. But that managerially and operationally independent of a constituent systems. So that means if you, let's say, have an airport, or actually an air system, right? You have the airport themselves. You have, if you recall from the SE handbook, you have the fueling system. You have the passengers. You have the actual like United and American Airlines, right? The different airlines that operate independently, and it's really a challenge to make sure that all of them are coordinated. And so what you can then see, or what you have, is that you have four different types of system of systems, and depending on the level of, let's say, grip you have on those subsystems or constituent systems, you can either have directed, acknowledged, collaborative, or virtual system of systems. And let me actually go into full screen mode over here. And it really depending on the actual system of systems, you then either have a manager or you don't have a manager. So for example, for the directed one, you have a dedicated system of systems manager, and those constituent systems are actually subordinated to the manager. So it's technically like systems engineering. An acknowledged system of systems you have SoS manager and resources, but the actual constituent systems are independent. So somebody is declared to be the manager, but you don't really have a lot of authority. But at least already you have common objectives, right? And then when it comes to a collaborative system of systems, you actually have only like the silos, so to speak. So you have those independent systems. Nobody is really the manager, and really the intent to to work together comes from the individual constituent system. So there's no manager, and it's really based on voluntary interaction. And then virtual, it just happens. Yeah. So you take your coffee maker, plug it into I don't know, your outlet, and that becomes a system of systems, right? So the fun part of all of this is actually emergence. So it's a key characteristic of system of systems. And so the idea is that you bring those systems together and then they do something. And what's really tricky is because of the complexity of all those constituent systems, that if you bring them together, what can happen is this unexpected behavior. So not only unexpected, but also unintended consequences. And so really, managing those, that unanticipated behavior and emergent behavior is really the key challenge of system of systems. So if you're interested in reading more, that's actually a primer. So if you go to the INCOSE store, you can find this system of systems primer. And so the page you see over here talks actually about so-called pain points, and like authority, leadership, constituent systems, autonomy, emergence. So those are all things that really the whole systems engineering community hasn't really figured out yet. It's really tricky. And I will actually get back to those, you will see in a couple of minutes. So let's talk about high-speed rail for a second. So this is a project I'm working on for almost 10 years by now. So let's just a very brief overview. And so basically what is this? It's one of the largest and most ambitious public transportation programs in the U.S. history. I just reading, more or less. Eventually it will go from San Francisco to Los Angeles, phase 1 it's called, and then finally Sacramento to San Diego. Trip times of up to, but trip times under 3 hours, 2 hours, 40 minutes. The speeds of up to 200 miles per hour, which is in kilometers per hour over 350. And it's using federal funding, state funds, cap and trade to be built. And that's actually 3 active civil works contracts going on that have started in 2013. And, the next real interesting contract would be what we call the track and systems contract. So I'm really looking forward to actually finally getting out of concrete and doing something more, let's say, systems related. So, one of the most important aspects actually of the program is the procurement strategy. And that's why I'm bringing this up here, because what will happen, you will see, is that those procurement contracts really become the actual key elements of the program, right? So you have civil works, you have rail infrastructure, you have rolling stock, and the operator. And so what will happen, what's happening right now is we are building infrastructure. So as you can see to the right, it's actually what they call a roadway overhead. So basically a roadway relocation, right? And you can even see it on the picture, so that there is, without any barriers, the trains can travel with high speed. And on the left side, the graphic you see is actually one of the viaducts which will actually hold the train. And so now let's talk about why is high-speed rail a system of systems, right? So if in itself, high-speed rail, the whole program is technically even a system element of a much larger system. And if you wonder why, take a look at this one here, right? It's just one of the YouTube videos you can see. And so what you see is we have adjacent railroads, for example, right? Typically freight railroads, and you can see in the upper right corner, where we have to cross over a freight railroad, you have adjacent highways. You saw already that we had what we call a grade separation, where the roadway has to be relocated. We have power utilities, which actually bring in the power to feed the electric trains. California is it's a earthquake country, so we will have to have seismic detection, but we're not going to build a new system. We tie into an existing one. So that means high-speed rail itself is really depending a lot on other things, the contacts, right? And it's something that we sometimes seem to forget when we build a system. It's fun to build a system, but it has to tie in into the existing environment. And so another level of why high-speed rail is a system of system, and in this case, actually what I would like to call this a program of projects, is once you take only this high-speed rail portion, what you can see is that on the program level, it's actually broken down into a number of projects. Right, and those projects we call, depending on whether it's civil works or tracking systems or train sets, basically those are the constituent systems of a system of systems. So you can argue that the high-speed rail system itself, it's a program or a system of systems, of which the projects of the constituent systems are basically the parts of it, right? And so not only do we have to plan for all of those procurement packages and contracts or projects, however you want to call them, but you also have to integrate them at the end of the day. And then there's one more level that I'm arguing is that if you take now this breakdown of the program level in the upper right corner of the project, if you just look into even the program level, if you look into the organizational structure, so basically what you're seeing is that the authority obviously is, has a chief executive officer, it has a board, it has a program delivery office, and you can see already there's many, many different departments to the side, whether it's legal or whatever, right? There's many different departments, and then the program delivery office again breaks down into infrastructure delivery, rail systems delivery, strategic delivery, and as part of the rail systems delivery, they actually have a network integration team, and the red little button down there, but this is actually me. Yeah, this is the systems integration position, and so what you can argue is that all those different departments, you can treat them like individual system elements that come together from an organizational perspective in order to make up the system. And in this case, that the system is the organization, right? And again, the same, things apply in terms of having independent management, right? Every group has a different budget, different managers, and they do obviously have the intent of doing the right thing, but they can technically do their own thing. And it's not easy, especially in large organizations, everybody knows, to make sure everybody marches to the same sheet of music. anyway, so much of a brief introduction. So now I want to talk about the system of systems engineering challenges we faced. And I have to take a look first into a traditional approach to the industry. And when I say industry, I mean the US, and specifically the transportation and civil works is even a bit worse. And then what does this mean from a systems engineering perspective? Or SoS, actually, system of systems engineering perspective, what kind of challenges we face. So let's take the first one. So you're probably familiar, at least if you work in the US, with the terms design bid build and design build and whatnot. So there's a whole institute, the Design Build Institute of America, right? That this is where this information was taken from. So typically, the traditional method was design bid build, means an authority, either or an agency, performs a design, right? In-house design or preliminary engineering, and then going to the final design, also critical design. And then basically they issue an RFP, right? Request for proposal, and then a company steps in. This is what happens next, right? And then basically a construction firm comes in, and then basically they build it. And so can you see that basically the design bid build is the design part, the bid part, right? And then the actual build or construction part. But what happens is, because most agencies are very, let's say, hierarchical and functional in terms of you have an electrical department, a civil department. So what happens is they develop all their own individual designs. And in the past, what happened, they were not optimally integrated. And so what happened is the construction firms came back and said, hey, your lighting system is conflicting with the sprinkler system, is conflicting with the HVAC system. And so basically what happened at the end of the day, this looked like a lot of kind of this picture over here, right? Basically getting together a system that is not easily integrated, and resulted in lots of claims and change orders. And then finally, the industry reacted and said, you know what, I'm done with this, you do this, right? So basically this is what's called now a design build. So the agencies now go and just perform preliminary engineering, saying, you know what, dear construction firm, why don't you do the design? And so then you can't claim anymore, right? Because whenever you design something wrong, you are on the hook. And really what this resulted in was really kind of a risk transfer to the design and construction firms. But it also meant that there's really not a lot of knowledge anymore on the agency side of what exactly is being, the final design and what is being built. And that really, results in a whole slew of different challenges. So let's take a look at this from, the consequences of design build. So now nobody wants to be specific anymore, right? It's like, if you're too specific, that means you're kind of, you go into the details, and then that is quite often, basically interpreted as giving directions. And then those directions might be different than what the contract says. And then again, the contractor comes back and claims. So really, there's always, the attitude of saying, don't be too specific, right? Just describe requirements and not the how-to or the implementation details. That by consequence means also there's no known integration scope, because the design and construction firm is actually doing now the final design and construction. That means the agency doesn't really have any knowledge of a final solution, meaning there's no known system architecture or even the resulting interfaces. There's really a big hesitance in providing any details in terms of interface list or description of interface requirements. And also by just providing, even if they did this, providing a list, as soon as you miss one, the contract comes back and claims. And then also the whole idea of innovative, the idea of design build is to come up with, quote unquote, according to the Design Build Institute, innovative design and construction, right? So saving time and money by encouraging collaboration and innovation. What this really means is, the triple constraint, time, money, and basically scope, right? It's pick any two. So if you're focusing on time and money, then whatever, is being built is quite often short-circuited, yeah? And this more often than not results in things, in emerging unanticipated behavior, as we just talked about from an SOS perspective, that the clients did not expect, right? And saying, oh, look, we thought we'd get this fancy swing, right? But, and then at the end, you get something completely different. And so what does this mean to a systems integration perspective? So really, the whole systems integration quite often is then described only as a responsibility in terms of coordination. There's a huge risk avoidance approach of saying, don't tell the contractor anything, just hands off, leave it to the contractor. And it's, and obviously if a contractor does that, that's already late in the process, right? During final design, construction. And so anything you identify late, obviously, is far more costly than as if you do this at the beginning. So let's quickly, this was, basically what the industry does. So let's take a look at this from a systems engineering challenges. If you recall the pain points I showed earlier, so one of them is SoS authority, right? Meaning if you are managing independent systems, you can't tell them what to do. And that's exactly what this means of authority. So if you remember this org chart over here, and now basically the authority issued already 3 different contracts, and there's going to be more, right? And let's just call them project 1 to N. They're actually managed by independent construction management firms. They have an independent checking company. And finally, you have a design build contractor. So just look at the org chart, how many levels I would have to jump to tell them something. And so really, basically, from an integration perspective, we have to integrate those 3, current design build companies. And it's a huge challenge, because at the end of the day, they don't even report to you directly, and that's as you can see, right? Another one is the SoS architecture. And as I said earlier, the architecture of a whole program is really the procurement contract. So let's take a look at those, right? So if you go to the authority website, there's a link down there. You see the design build construction packages, right? You recall we just talked about design build, so there's civil works. And already, as you can see here, it says construction package 1 to 3, and the first one started in 2013. So if you go to the next one over here that says track and systems, so that one is actually being negotiated right now. So there's the RFP was issued, companies came back and offered. So right now it's being negotiated. So it hasn't been released yet. It has not started yet. And so one of the challenges is if you take those 2, basically the civil works contract that started in 2013 and the track and systems contract that will start in 2020, and then you take a look at the procurement strategy in the upper right, then we're covering only 2 of those 4 types of contracts. So there's still the train set contract and the train operator contract. So the authority is not going to operate that on their own. They're going to hire another company who is running this, right? So now we have 4 different types even only of contracts, not even the number of contracts. As I said earlier, civil works definitely is several contracts already. Probably going to be more like 5, 6 or so by the time we are done, at least initially. And so what you can argue now is back to the program and the architecture, right? What you can argue now is that those procurement contracts of a project are really the system elements of a constituent systems. And so the architecture is the collection of all those procurement contracts. And if you look at this from an SOS leadership perspective, which is another pain point or challenge, as I just showed you or told you that the industry has really a big hands-off approach, right? So those are quite a number of challenges. And then another one is that once you go into issuing the civil works contracts, that they want to know, if they want to build, let's say, a tunnel, and I'll show you on the next slide, or if they want to be a bridge, they want to know how big is it, how strong does it have to be. There's a gazillion things that need to be coordinated, and I'll show you. So let's take, as an example, a piece of infrastructure. This is the easiest one to explain. So this is the tunnel cross-section, right? And the civil contractor typically only builds the outer shell, meaning actually the hole, so to speak. They dig a hole in the ground, they put some concrete up, and it sounds very easy. It's obviously more complicated. But they need to know how big is the tunnel? How big, should it be? Every inch of foot costs millions and millions of dollars. I kid you not, yeah? And so they're obviously trying to optimize it to as small as possible, but also as big as necessary. And so the things that need to be considered, for example, what you see here is the actual size of a train set, right? Which is a train set contract. You need to know for safety, security purpose or maintenance purpose, you need a walkway, right? How big is the walkway supposed to be? The track, right? And the train is going to run on. Is it ballasted track, non-ballasted track? Yeah. Any system you put into the tunnels, like the radius system, it has to have a certain distance or clearance from the trains, the power systems, you name it. So there's a lot of things you need to know up front in order to design the infrastructure correctly. But how do you do this if nobody wants to be specific, right? Especially with those contracts that come later on. And so basically, what really, what the conclusion here is the interface requirements are needed early on from the contracts that are not even issued yet, right? Which is, the key challenge. And last but not least, the emergency we talked about, which is the key challenge. So what I'm showing you here is basically a trench, a cross-section, meaning showing a trench. It's like a tunnel without a lid, so to speak. Typically, that's the configuration you see in New York with the subway systems, only that in this case it's open, right? And so this picture you see here is what was put into the contract as a scoping document, meaning this is what we would like to see, right? They identifying all the key elements and saying, hey, this is the trench, and here are the key pieces, and this is what is part of your contract, but not. But what you see is a very, very solid foundations, right? Very solid walls. And what is highlighted here that the overhead contact system that is powering the trains is wall mounted. And so when the contract was done, right, this is how it looked like, completely different. So the idea of putting the catenary to the wall was completely dismissed. Yeah? And so if you take a look, you can see over here, the actual wall is that thin strip here. It's almost like wallpaper. Yeah. So what they did is they decided to use, piles and put them into the ground every so often, and then but just put a little bit of I don't want to say cardboard on top of it, but a very small wall, a very thin wall. And obviously, again, this is all about saving money for the contractor. And because of that, they had to redesign the complete overhead contact system. And the challenge here is to make sure that all those interfaces, all those needs from future contacts like catenary, walkways, as you can see, right, they're all still adhered to. And if you're not careful and don't be specific, the contractor's going to squeeze you as much as he can, right? So the point here is that those pieces that have to come together as one program are so flexible and so they're ever changing, and you have to be careful that they're still integratable at the end of the day. Anyway, so let's talk about the activities you perform to address those challenges. So the first step we did is we performed, what we call an international best practice, and so we looked into, basically globally high-speed rail, especially Europe, obviously, and Asia, right, where those trains are run. And at the end of the day, I'll show you, we settled for one good documented system. And then I want to talk to you about the SoS integration strategy, and then also step-by-step walkthrough of how this all works. So the first step is obviously in Europe, right? Those countries are hundreds of years old, and the rail systems were developed in the 1800s. And then obviously every country came up with their own little system, right? And even within the countries, they came up with their own railroads. So by the time they were trying to integrate this into a high-speed rail system, every country had, as you can see, a different structure gauges in terms of the size of the train. And I like really this picture from the London Underground, right? The tube where you see the tunnel was obviously built like 150 years ago, and then the trains are being replaced, quite often over time. And it's a perfect shape, yeah. So in this case, the train adapted to the tunnel, but you can see how how we attempt to integrate and utilize as much space as possible. There's different track gauges. For example, in Spain, they still have a different track gauge, different power systems, AC, DC, you name it, all the different voltages. And so nowadays you have, the European high-speed rail system integrated, and we were wondering, it's like they did this. So how did they do this, right? And so I'm showing Eurostar, and in all fairness, Eurostar was actually one that was developed in the 90s and still was really hampered by all the different standards. But at the end of the day, the point is nowadays you can really go from London to Paris to Amsterdam, you name it, right? And so what the Europeans did in '96, they issued what's called the technical specifications for interoperability. And that's really kind of the key source of where we got our thoughts and ideas of how to integrate high-speed rail in the US and California. So what those TSIs, again, the technical specifications for interoperability did, they broke the whole high-speed rail system into 8 subsystems. 4 of them they called structural subsystems: infrastructure, energy, control, command, and signaling, and rolling stock. And then every document or every subsystem really was described using the same format. That was really helpful, yeah. And so the section 4.3, and here, if you can see it, for every single one of those describes the functional and technical specifications of the interfaces. And so this is obviously, it says down here, the one for the infrastructure. And then in a very similar fashion to an N2 matrix, let's say, so infrastructure interfacing with rolling stock. Yeah, and then interfacing with energy, interfacing with, you get the idea, right? And then in there, they're actually listing all the interfaces in here. And so that you can almost say this is actually a collaboration in terms of system of systems, how they developed this. There was not really one document that used into all the subsystems. Every single document of those had a cross-reference to the other ones. But it was still very helpful identifying the key interfaces over here, and then making reference, in this case, to the infrastructure document and then to the rolling stock document. And I'll show you on the next page. Basically, if you pick this one interface, which I'm using as an example, now making reference to those documents. So can you see it says structure gauge over here, and then it says, hey, infrastructure PSIs go to section 4.2.3, right, which is this one over here. And then it says, hey, this interface between those two parties is now the interfacing party is rolling stock. And then rolling stock go to the section 4.2.3.1, which is this one over here. And then both are basically described in the way that if every party did what they were supposed to do, you would have an integrated system at the end of the day, right? So one described the infrastructure, one described the train sets. And if every single one did what they were supposed to do, it should work. And then either they described the interface requirements or implementations directly, or made reference to appendices or even acceptable standards that are out there. So in this case, actually, making reference to an appendix, which describes the interoperable interface standard. And so we really thought this would be very powerful in especially following that example. So so how did we, looking into the SoS SoSE challenges, again listing all of those like leadership authority. So what we thought is, okay, so the interoperability approach is really the one we chose at the end of the day. And from a leadership position, we just did it. We said, you know what, we have the integration team, so let's do it, right? And from an authority perspective, obviously the integration team, was authorized to do, integration, and that's mostly understood as technical integration. So nobody argued with us doing the technical integration. So we basically just ran with it and had, at least the felt authority to being allowed to do the integration even across the organization. So we're focusing really on technical. Then from an architecture perspective, right, SOS architecture being one of the challenges, as I showed you earlier, it's just presented a bit differently over here. So you have a program, right? Basically, this is where you define the architecture, the individual key elements, the constituent systems, and at the end of the day, we knew this all had to be integrated. So on the SOS level, basically the program, and then the constituent systems are the projects. And then when it comes to collaboration and integration, now we can have basically for 4 different parties, if everybody interfaces with everybody, you come up with 6 relationships, right? So you can see several works, integrating the interfaces of tracking systems and train sets. And so if you, for example, have a civil works contractor, you would have to make sure within your box, right? Within your bubble, you can do whatever you want as long as you meet your requirements, but you also have to meet the interfaces with the other parties. So, and what we said is we on the program level would be the one identifying the interfaces and define the interface requirements or specifications to the detail possible. It's not always possible to do everything you want, but at least to a degree you can. And then those constituent systems of the programs would be responsible for implementing those interfaces. And then last but not least, right, the autonomous constituent systems and the emergence. So those contracts, they would be able, so first I would have to, so we would define those interoperable interface standards, and then those, projects would be able to do whatever they want, quote unquote, almost, yeah, as long as they meet the interoperable interface standards. So if you recall what I just showed you about the trench, right? They can redesign the trench, they can redesign everything they want and build even differently as long as they meet the performance requirements and the interfaces. So, and that resulted in an integration strategy, which can be presented in this very simple 7-step process. So the first one is really the system of system architect, which happens to be the integration team, would define the key interfaces. And when I say key interfaces, not every single interface is being identified. So for example, if you have the civil works contract and you have internally, let's say, a structural team and a drainage team and whatnot, so you don't need to micromanage those. What's really important is between those constituent systems, right? And then in the second step, and I'm using the example for the clearance diagram. So in a second step, and in this case, the high-speed rail team will identify, basically the subject matter expert will identify what we call candidate high-speed train sets, high-speed rail train sets. And then step number 3, we would identify the interoperable interface requirements. Step number 4 would be that the civil team, in this case, right between the rolling stock and the civil team, would identify or would develop the interoperable interface designs. So these are the requirements in this case. These are the interface designs. And as you can see, it's still everything is blue. That means all of this needs to be done on the program level, which itself it's a huge challenge. Yeah. So if you recall that nobody wants to be specific. And then if you move on, then unfortunately the civil works contract goes first, so they have to build this first, right? And then later on, we're going to have the train set contractor, which is yellow, right? Those individual contracts. And last but not least, then the integration occurs down here, right? And so the system of systems system integrator would integrate, test, and commission the system. And typically that function is delegated to the last poor guy on the graph, which happens to be the systems guy. Yeah. So it's being delegated quite often. Anyway, so let's go through step by step, right? Step 1, identification of key interfaces. As I told you already, so this is the architecture over here. Can you see the 4 key packages or elements? And this is, this example would be between the train sets and civil works. And if you can see the B, right, this would be basically the B interface. And it's not only one interface, it's a whole slew of interfaces, you will see. And so basically what we would do is we would make sure that we identify the interface requirements and then make sure that the interfacing party would design the interoperable design, so to speak. So also it's still step 1, identification of key interfaces. I showed you earlier, and I just mentioned also that the TSIs are independent documents which cross-reference each other. And so one of the first steps, very years ago, at least 8 years ago, so we developed an interface register by doing nothing more than identifying all the interfaces. So this one here over here, can you see this is TSI infrastructure interfacing with rolling stock. As you can see, it's all done indoors. And that's tracing directly to the TSIs, which we all import into doors. So now you can filter, can you see it says here infrastructure and rolling stock. So you can filter for all various types of interface, let's say possibly like mapping. And then what we did is we tailored those interfaces to, and we looked at every single interface and said, is this something that should be concerned to us, right? So you can see this is one interface over here, but we created 2 in our own interface register. So we separated the static gauge from a dynamic gauge, meaning one train basically not moving and then the train moving as 2 different interfaces. And then also that resulted in originally 49 infrastructure interfaces of rolling stock, or actually only infrastructure interfaces of over 100 interfaces that we tracked and basically in our own project. So you probably, if you recall, if you ever go through the CSEP certification, never ever use a baseline from a different project without, tailoring. So you can't just copy and paste. You have to think, of does it make sense or not? And then also this was, I know I keep focusing quite a bit on civil because just because it's ongoing, but also can you see you have interfaces between energy, right, the voltage and frequency, between the power system and the trains, or between the operation, right, and the train. So there's many, we have hundreds of interfaces, we have to deal with. And then also what helped is the infrastructure itself, the civil works, so to speak, is breaking down again into 4 key configurations. So you have bridges, which we call aerial structures, or you have embankments, what you call at-grade. We have trenches, tunnels, right? And then what we did is we took all of those interfaces and then saying which interface applies to where, and then we took all the different, designs from all the different disciplines and made sure they're integrating with highlighting what the interfaces are. So that really helped, and even just determining what are the interfaces and coming to an agreement. And as you can see, look, this is a full build-out, right? And this is only what the civil guy built. So we better make sure that all of this stuff, right, can be built later on here. So, I mean, if you ever have to go and to hundreds of miles of infrastructure and modify that, that would be a very costly mistake to make. So step number 2, right, identify the candidate high-speed rail solutions for this example. This was our, subject matter expert on high-speed rail. And they looked back then and into over 30 commercially available high-speed rail train sets that were operated in China, France, Germany, Italy. I mean, you can read, right? And so what happened is we had our performance requirements of how fast the trains had to be, the size in terms of passenger load. And at the end of the day, we came up with what's called candidate train sets. And then what we did is the next step, developing the interoperable interface standard. So in this case, you have a Shinkansen, for example, right? And then you have a TGV. And so you can have double-decker trains, and you have the Shinkansen extra wide. So we couldn't really rely on existing standards. So basically what happened is then we developed our own standard, right? By just even overlapping all the different envelopes, and then developed one that became our standard. That's really the interoperable train set envelope. And as you can see, it looks like a train. And this is all about the catenary and the pantograph. And then finally, last but not least, taking this one and deriving the actual infrastructure needs out of it. And then obviously the trains, if you ever took a train and, go into a curve, the train leans into the curves, right? So you have to make sure all of this works. And so this is step number 4 already. And so now step number 5, saying, okay, fine, now we know how big, the infrastructure has to be for this specific interface. Now we can go and issue the civil works contract. So again, if you look into this, right, the 4 different elements, it's just between those 2. And so what we did is we gave now the civil works contractor all the interfaces that we had identified. So can you see this is an extract from a procurement contract that is actually available online. So I'm not sharing any secrets here. And it would say rolling stock, and then the train sets, and then interfaces guideway. And can you see this one line, what I said earlier, is really many, many interfaces. Yeah, it's about the track alignment, meaning, how sharp can the curves be, how steep, and then the gauge, we talked about this, and many, many other things in terms of axle loading and structure interaction. So there's many, many different things that need to be considered. And then going into the actual design and construction. So this is an actual design from what we call the Fresno trench. So this is how it looks like. Remember the trench, the catenary poles being on the inside over here, right? And so this was the design. This is being built. And so we better get this right. That's all I can say. Yeah? So you need to know upfront. You can't leave this to the contractor because they're just going to make this, a foot or 2 feet smaller because it just fits them. And you have a huge problem later on if you want to put your trains in there. And then as part of the civil works design, we have what we call a trust but verify approach. Continuous verification, we call this a V&V process. So the contractor, with every submittal they give to us, they have to do requirements management and have to understand the complete set of interfaces they have to deal with, which if you have, let's say, a trench design, which interfaces apply to a trench, which apply to an add grade. And then we have two different trenches. We have, Fresno trench, and another one's called Jensen trench. And so they have to give us a list, and this is just an excerpt here, a simplified one that we call certifiable items list. And in here is actually the interface we just talked about. And then they say, okay, in my submittal, it's on sheet number so-and-so. Yeah, so basically, with this submittal, they have to give us what we call a V&V submittal. They have to list all the criteria, all the interfaces in this case that apply, and then have to demonstrate compliance to us, meaning this interface is addressed on this drawing as the name says over here, right? So can you see the clearance diagrams? So we can be assured whatever infrastructure they're building is ready to take on later on the future contract. And then, so last but not least, right? So now, if you have, performed step 1 to 5, if you recall, right? And we are in civil works right now. The next step would be now to build to procure the high-speed train sets. And as you can see, look, we started out with so first we identified the interfaces, we identified the candidate train sets, we have the interoperable envelope, right? The train set envelope, and then we gave this, can you see the interface B to the civil group, and they defined the infrastructure gauge, and then they're building this. So now if the train set contractor is picking any one of those trains over here, right, basically sticking to whatever what our candidate train sets are, otherwise you would have to follow the change process, then those two should perfectly integrate at the end of the day for this interface, right? So the only thing you have to do, quote unquote, only is do this now a few hundred times for all the different interfaces. Anyway, that's really what the whole process is. So let me just walk you through quickly of what I just showed you, and then also what the achieved outcomes were. So basically, what I just did is I showed you a little introduction to system of systems, and also told you that you can go to the, to the INCOSE store. Briefly talking about high-speed rail, talk to you why high-speed rail is a system of systems, talked about the challenges, the typical industry challenges, without even looking at this from a system of systems perspective. Then I actually talked about this, what this means. If you look at this from an SoSE perspective, such as EMERGENCE, then look into best practices, right? What are other countries doing? What can we learn from this? And then our own approach, what we basically tailored out of this. And I walked it through how it's being done and how this all leads to successful integration. So having said that, what will we achieve outcomes? So specifically from an SOS perspective, from an authority and a leadership perspective, basically what we did is we maximized our authority by focusing on the technical systems integration. If you try to go into the realm of business process modeling and organizational integration, you get probably your hands slapped quite often. Yeah. We also demonstrated leadership by developing basically a tailored system of systems integration strategy based on proven international best practice. We could always say, hey, if you don't trust us, trust those guys, right? So really reference power if you want. From an SOS architecture perspective, the architecture really became the procurement strategy. And since we didn't develop a procurement strategy, everybody accepted it because, yeah, okay, fine, that's one, I guess we do, right? And also what it really did is because it's only 4 key elements, it was also very easy to work with our, having key stakeholder buy-in. And in terms of collaboration and integration, we work closely from an integration perspective with all the subject matter experts. As you could see, we worked with rolling stock and the integration, right? And also in terms of autonomous constituent systems and the emergence, really what this whole approach did is we allowed what the design build is looking for to have contract innovation and allowing what we call SOS emergence without negatively impacting or affecting the integration as long as it sticks to the interface. And that really the final conclusion then is that our tailored high-speed rail systems integration approach created a modular and interoperable constituent systems that can or could be or are still being effectively integrated into a system of systems. And really what the whole title of the presentation is, right? Achieving systems integration through interoperability. Anyway, I'm done. Any questions? How are we doing time-wise?
Yeah, we got around 10 minutes, Oliver. Yeah, feel free to unmute yourself, say your name, and ask Oliver any question.
Oliver, it's Bruce Elliott speaking.
Hi, Bruce.
I have a question. This approach is thoroughly sensible, but as I understand it, relies upon defining interfaces in order to control the interactions between the systems. The history of railways is dotted with various completely unexpected interactions, resonance issues in traction, and sometimes between the bogies and the track, causing corrugation in the lines. So that sort of unfortunate stuff does happen. Do you think it's still a little bit of it is still going to creep through? And if you do you have plans for dealing with the unexpected interactions?
Yeah. So Bruce, I fully agree, right? So it's kind of, you can almost say it's the known unknown and then the unknown unknown, right? And so not only do we give a contractor, the list of known interfaces, we also still rely on additional language by saying if the authority identifies an additional interface or if a contractor comes across an additional interface, then it has to be added to the interface register and managed accordingly and yada, 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 right? But I can, and that, by the way, that approach, you still find a lot that people, the challenges I talked about the industry, right? That people say, don't tell the contractor anything, as soon as you're specific, you take on ownership. But I give you an example, yeah? So we knew we had a specific submittal where we had identified over 30 interfaces. And the contractor came back with 2, yeah, and said, that's all it is. And so, yeah, I might have identified 31, yeah, and missed maybe 2 out of this. So, yeah, you can, get me on those 2 missing. But if you leave it to the contractor, you miss like 30, yeah. So don't rely on the civil, in this case, the civil works contractor, any contractor. If you have a fixed price contract that they do anything for free, yeah, it's. So the answer is we have additional language in the contract to support that. That's all I can say. And yes, it happens.
Do you think there is scope for the central team to go looking for some of these?
I'm sorry, say again, go looking?
You've talked about dealing with it in contracts, and I see that. Do you think, in addition, it's worth having a central team go looking for some of these unknowns, as you put it, so you can find them earlier and fix them when it's less expensive?
That's really what we try to do, right? That central team is the program, right? I'm working on the program. I'm not part of a contract. And so, yeah, that's what we constantly do. We're trying to learn, right? This is one of them, right? Sure. By looking at experiences or lessons learned from other contracts. And so in the meantime, we actually completely refreshed our interface register, but whatever lessons learned, we learn, yeah? We try to do to basically, learn and improve what we have.
Okay. Right. Thank you very much. Good on.
Mm-hmm. And Bruce, you once asked me about a case study, so this would be another case study if you ever, yeah.
Oh,
anyway.
yes, please. Yes, please. I will pass it on to someone else, but yes,
yeah.
I have witnesses to the offer. Thank you, Oliver.
Yeah, so let's take a look into the questions Gordon asked, how many in the team. So originally, we were only 2, yeah. You can only do as much as you can. And nowadays our team is a bit bigger, so we are roughly, I would say, like 7, 8 people. Is it ever enough? I think if you do the CSEP questions, that's 14% or so is the sweet spot. We are nowhere near 14%. Yeah, is it enough? Well, I can tell you, I'm already happy that we have an integration team with several people. I worked on other projects where this was much smaller, if even done at all. Yeah, not left to the contractor. So can you expand a bit on the organizational change management hurdles? Oh yeah, I don't know where to start. Yeah, and so civil contracts don't even know what configuration management is. Yeah, or change management. So we can just try to. Whenever something gets released, like a design submittal, that becomes by definition a version of something, like the trench, for example. You have the trench itself as part of the procurement package. That becomes obviously a baseline, or even a configuration item you want to manage. And then you have what the industry calls the 60% design and 90% design. And then there's a whole change process, what they call the design change notices and field change notices. And it's extremely tricky to stay on top. So for me, a change is always what I call the icing on the cake, and I see that's from Dale. So yeah, I know, Dale, you understand this as a key function that must be there before you even start, but reality is it's more like an afterthought all the time. Yeah, from what I have seen.
Sadly, yes.
Yeah. By the way, we actually do manage. Yeah, so we do manage requirements interfaces in our requirements management tool doors. We also track all the what they're called design variations, directive letters, field change notices. So we try to keep them have running logs with links to our repository into the design documentation and being able to track them. But it's not always easy. Yeah, it's a big challenge. That's all I can say. I see there's another. Yeah, 2 questions. In the UK, contracting different acquisition seems difficult, complex. So you talk about the procurement strategy acquisition. So I can tell you, it seems like I talked about using baselines, right? That should always try to apply. When you look at this, if you copy something over, and man, the whole strategy in the US, it looks like building highways. Yeah, you have the civil guys, and then you have the systems guys. If you're lucky, if I remember the 2nd Avenue subway in New York, the extension was the tunnel, and then every station was a different contract. Good luck integrating that. Yeah, every station itself needs to be integrated. anyway, so it seems to be a little outdated, this whole approach. Incremental development or deployment of operation, yeah, definitely. I mean, there's no way of building the whole thing, right? Even the initial, they call it at some point in time initial construction segment, initial operating segment is between Merced and Bakersfield, which is, I think, what's it like, building 120 miles, 200 kilometers, and I think it's closer to like 300 kilometers what they're building. And then and that alone is already several civil contracts, as I told you. So you can't feel it's incrementally built, but even the initial operating segment then is extended to the north, towards San Francisco, and to the south, towards Los Angeles. That itself, and then there's actually, I believe it or not, I would say agile, but there's something like the civil procurement methods where you have gradual kind of progression. Yeah, I'm not remembering the name right now, but it's kind of where you have like a 60% design, and then you take a look at this, and then you decide again how you want to proceed to the 90% and 100%. So yes, something like that exists in the US and also at high speed rail.
Hey, thanks, Oliver. Appreciate it.
Yeah. Oh
Hey,
yeah.
Oliver, this is Vijay.
Yeah, I see. You said something here, but yeah, obviously, feel free to email to me. I think the time is up. If any questions, any concerns, any paper ideas for next year, right? Honolulu, I'm just saying.
Yeah, we can give VJ last question.
Yeah. Hey, Oliver. Thanks, Dale. Appreciate it. Oliver, good presentation. I know we've been involved with my high-speed rail since the start of the project itself about 20 years ago. But anyway, it's a good presentation, and you really clearly articulated in how the systems approach is interpreted here. But again, I just want to make a note that it doesn't have to be such a big project to have this kind of a approach. I mean, even a smaller project still has similar kind of elements that have to be implemented. And unfortunately, yeah, the amount of time that it takes upfront is humongous. But in the long run, this is much better than going back to the contractor and then having risks or basically challenges with costs and things like that. So fortunately for us, I am seeing this change happening in the transit sector. At least a couple of projects that I have seen recently where we have been part of, there is an integration manager position that is being identified, and there's a clear scope that is being identified across all the systems. So at least we are moving in the right direction. We are making sure that the industry is getting educated about not only systems engineering, but systems approach, things along those lines. So the more we do these kind of things, the more we educate the industry, the better it is, because over a period, the life cycle cost of the project is going to be lower by using this approach. Unfortunately, our industry is always looking to cut costs, and the cost that they cut is more in the planning and the design arena than in the actual construction arena. So hopefully we can educate our industry more about this particular approach.
Yeah, it's good things to then talk about this, right? That's what we're doing here with with our TWG and APTA, and saying, hey, It doesn't have to be this way, right?
Yep.
This is what is being done in other projects. Maybe it's worthwhile considering something in your project as well.
Yeah, absolutely. Good job.
Thank you. And thank you for Gordon, and everybody else for your interest. Hoehne, back to you.
Yes, well, thanks everyone to join us today. Fantastic presentation by Oliver. If you want to review any part of this, you can go to YouTube in a day or two, and feel free to watch it throughout it, and remind yourself the impact of systems and also the systems engineering, the ties to program project management. So next month, as we said earlier, we'll have APTA and INCOSE, the languages with the new memorandum of understanding between two organizations. And we'll see you next month, everyone. Thank you so much, and have a great rest of your day.
Thanks, everybody.
Bye.
Thank you.
Thanks. Bye now. Well done, Oliver. Appreciate that. I'm glad we had you. Well, you want to do another presentation sometime for the for the rig or anything else, let me know.